Hello, students. Um, I'm just going to little video here for subatomic practice. You're going to have an assignment. You should have read 4.2. All this information is in the reading, and this video hopefully can help you. Hopefully, you'll learn what a subatomic particle is, talk about what an element's atomic number is, what's an atom's mass number, and isotope. All right, then the skill here is you're given any atom, how do you determine the number of protons, electrons, and neutrons? All right, subatomic particle, submarine. Think of a submarine. Sub means below. So when you have a subatomic particle, it means below the level of an atom. They're parts of an atom. Three main subatomic particles: electron, proton, neutron. Electron has a negative charge outside the nucleus. Mass is insignificant, so we call it zero. Proton, positive, part of the nucleus, and 1. Neutron is neutral. It has a charge of 0. So it's also part of the nucleus, and it has a mass of 1 as well. Just to note, the electron does have a mass, but it's so small we can call it 0. Atomic number. Atomic number is unique for each element. It always equals the number of protons in an atom of that element. So hydrogen, because it's atomic number of 1, it's the only element with an atomic number of 1. And every atom of hydrogen has exactly 1 proton. Calcium, atomic number 20. It's the only element with an atomic number 20. And every sample has 20 protons. Every atom of calcium has 20 protons. Gold, here's the little box of gold on the periodic table. Atomic number 79, you can see that's the atomic number. That's what the question mark is. So that means that's every atom of gold has 79 protons, and that's the only element with atomic number 79. Atomic mass units. So this is a unit of mass that describes the mass of an atom. It's exactly 1/12 the mass of a carbon atom with mass number 12. What's mass number? Well, mass number is the sum of protons and neutrons. Remember we said neutrons and protons both have a mass of 1 AMU, and electrons don't have a mass. So all we need to do to find the mass number is to add up protons plus neutrons. And that will give us what we call the mass number. Isotopes. Okay, most elements on the periodic table have different versions. We call these different versions of the same element isotopes. Of course, protons can't change, but neutrons can change. And because neutrons varies from one atom to another, these isotopes have different mass numbers. Here's an example, carbon 12. The one on the left here, there's carbon 12. And on the right, we've got carbon 13 in the purple here. Carbon 12, there's 6 protons, but there's also 6 neutrons. In carbon 13, 6 protons, but 1 more neutron. It's got 7 neutrons. That's why there's a mass number is 1 higher. All right, we can use all this information to calculate protons, electrons, and neutrons for any atom. You can use your periodic table for this. I don't know. So we got carbon, its symbol is C, atomic number is 6. Ni, that's a symbol on your table. The name is nickel, and atomic number is 28. Nobody expects you to remember the atomic numbers for each element. You can always use your table and look them up. Protons equals atomic number. Electrons, number 3 here, the number of electrons is equal to the number of protons. If you're given a mass number, then you can find number of neutrons by taking mass number minus number of protons. And lastly, number 5, you're given neutrons, then mass number equals the number of protons plus the number of neutrons. We'll practice this here. All right, so they're in blue on this table. You can see these are things that you can look up on your periodic table. So hydrogen is the name. Symbol is H. That's on your periodic table. Atomic number 1. All right, now the white columns are things we have to figure out. So they give us the mass number is 1. Atomic number always equals protons. So the protons here is 1. Protons and electrons equal each other out, so the atom is neutral. And then neutrons, you subtract 1 minus 1. Mass number is the first one, minus the protons equals 0 neutrons. All right, so you can try the rest of these. I'll go through just verbally helium here. Helium is on your periodic table. Its symbol is He, and its atomic number is 2. Look that up on the periodic table. So that atomic number means there's also 2 protons and 2 electrons. Now to find neutrons, we take the mass number, which is 4, minus the atomic number, which is 2, and that gives us 2 neutrons. 2 neutrons. So helium will have 2 protons, 2 electrons, and 2 neutrons. Boron is done down here as well. Atomic number 5, 5, and 5. How would they get? They got 6 neutrons is given, so to find mass number you add, well, the 2 particles with mass, the protons, which is 5, plus the neutrons, which is 6, and so 11 is the mass number. All right, the back side of the assignment here, the next page, I guess, uses these shell models. Use the key over here. And you can also use your periodic table for the symbol and name. If you look at atom 1 is pictured up here. And number of protons here, that's going to be, well, I count up the little positives, 3. Neutrons, well, look at this. It gives us a symbol here, those little circles in the center here, 4. Electrons, just need to look at these here in the space around the nucleus, 3. So atom 1 would have 3 protons, 4 neutrons, and 3 electrons. Atomic number, well, we said it's always equal to the number of protons, which is 3. Mass number, well, this you need to add up. So you take protons plus neutrons. In this case, it's 3 plus 4. So mass number is going to be 7. Symbol, look it up on your periodic table. Symbol, the only element on the periodic table with atomic number 3 is lithium. Its symbol is Li, and the element name is lithium. All right, so the rest of these, hopefully you can do without too much trouble. Good luck. Reach out to me with any questions.